Good morning, folks. Good afternoon, folks. And good evening. My name is George Pope, otherwise known as the Research Guy. Today I brought you a paper that's near and dear to my heart because number one, it was the first scientific paper that I was actually interested in reading about. And number two, I think it's pretty novel. This paper is from Nature. It's under their scientific report section. It was accepted into the paper in June of 2015. It's called The Identification of Urine Protein Biomarkers with the Potential for Early Detection of Lung Cancer. Now, this paper was produced by, excuse me as I butcher these names, Hongjuan Zhang, Jing, and Lin Li. The name of the paper, the link that I got it from, and the three primary authors are going to be linked in the description below, so you can go ahead and look at it there if you want to read the specifics. I'm just going to go over a quick overview. Now, this paper talks about lung cancer. In 2008, it had 1.8 million deaths per year. That's a lot of people. It affects a lot of people, from people who smoke cigarettes or cigars or chew tobacco to people who just have bad genetics and have a family history of lung cancer. So it's a pretty important disease, and we've been trying to treat it for a long time. These people kind of took an alternative route. They tested the urine of people who had lung cancer, trying to look for a novel biomarker in terms of a protein that might lead to earlier identification. Now, urine has received a lot of attention lately, specifically since 2008-2009, because it's been known to hold more than 3,000 proteins, which makes sense, because all of your blood gets filtered through your kidneys, and all the junk that gets filtered out goes straight to your urine. This could be anything from excess vitamin C that you take in dietarily, or just reactive oxidative stress that goes through. So what these people did is that they took mice that they produced lung cancer in by giving them a nasal spray. These are called genetically engineered mice. Took their urine after confirming that it was indeed lung cancer, tested for specifically a crass protein mutation, and then they compared the protein analysis from them with normal mice to see what was upregulated. Now, there were 4 specific things that were upregulated. All of them had to do with pro-growth hormones. This could be anything from cell adhesion to defense mechanisms to the immune system response and even inflammatory responses. So all of these pro-growth symptoms lead to the fact that the lung cancer was developing at a higher rate, and so it was metastasizing throughout the body, which is bad. So what they did was they then compared these results to the human cancerous urine that they tested. And they often found that a few of these select proteins were identical between the humans and the mice. Now, this leads to a really good potential biomarker for humans, because if it's positive upregulated in mice that have lung cancer and positive upregulated in humans that have lung cancer, but can't be found at an upregulated level in normal mice or in normal humans, then it makes sense to say that the proteins are due to the cancer development. Now, this was really beneficial for a lot of reasons. Number one, it was the first real paper that found significant proteins in urine that weren't caused from bladder cancer or renal cancer, from somewhere else in the body. So it kind of makes you wonder, can other cancers be found? Biomarkers be found in the urine that we didn't think of? Like melanoma, skin cancer. Maybe there's some stuff, floating around your urine that actually leads to skin cancer, that's produced by skin cancer. And it also kind of confirmed what people have thought for a long time, in that yes, mice models are amazing for trying to analyze what's wrong with a human, but until you have a mice-human comparison test, you don't really know if what you're finding is true, especially when everybody's using the same type of mouse, which we'll talk about in a different video and why that method needs to change. So yeah, that's kind of a neat little trick that these guys produced here in their lab. Let's talk about their funding and stuff, because I don't want to get in trouble by taking all the credit for these guys' paper. And you know what? I didn't print the funding page. So they were funded by some big organization. So congrats to them. Thank you for tuning in with me this morning, or this afternoon, or this evening. I know this paper was a little bit rusty. We'll try and get it into a better, concise method, and not try and repeat myself or say as much. Cheers.